Okay, so we're going to solve equations that have variables on both sides. So this is something new that you haven't seen before, but it's really not that hard. So let's get right into it. So the first thing to talk about is a nice helpful strategy. So definitely copy this down because it's something that will be good for you to remember. When an equation has variables on both sides, you must collect the variables on one side and the constants on the other. And you'll see what I mean in just a minute. But your goal, you're going to see variables and constants on both sides, or at least one side. And your job is going to be to get the variables together on one side, the numbers, or the constants on the other. Okay, so here's an example of what I'm talking about when I say we have variables on both sides. 2x plus 8 equals 4x minus 10. So we've got a variable we have an x on the left, but we also have an x on the right. Up to this point, you've only ever seen the variables on one side. Our process does not change. We still go through the steps the same. Simplify the equation. Remember, our goal is to get the x by itself. Then we undo all of our addition and undo our multiplication. So those steps are still in effect. It's just that now we have a little strategy that will help us get through the steps and still solve this problem. So the number one question students ask is, how do you know where to start? So definitely copy these tips down as well. So the number one question is, how do you even know where to start? Because remember, we want to collect our variables on one side and our constants on the other. So things are going to move around. So the first tip, after simplifying, so we're still doing our first simplifying step. So after you simplify, eliminate a variable on one side first. Okay, so if you choose one of the variables to eliminate first, that gives you the most control. You can eliminate anything you want first. You can get the x's together on one side first. You can get the constants together on one side first. You have a lot of options, okay? But an efficient strategy is to eliminate a variable first. Again, it just gives you the most control. Now, you'd have to ask yourself with this equation, do I get rid of the 2x first? So do I get rid of this first, or do I get rid of this first? How do you know which x should I, get everything on the left or get everything on the right? And to help you decide that, you could eliminate either one first, it doesn't matter. But strategy, eliminate the variable with the smaller coefficient first. You can add the word first in there or not. Oops. First doesn't really fit, but that's the first move, is to eliminate the variable with the smaller coefficient, I guess, is a better way to think about that. So if we look at our coefficients, this coefficient is a 2, this is a 4. Which one is smaller? The 2 is smaller. So this would be the first piece of the equation to go. We're actually going to jump right into an example so that you can see these strategies in action. So copy this equation down. This is the exact equation that you just saw. 2x plus 8 equals 4x minus 10. Of course, our first step is to eliminate our subtraction. Now we're going to look and we're going to eliminate an x first. This 2x, 2x's, it's smaller than 4x's. So this is what I'm going to eliminate. Now, up to this point, we only eliminated the coefficient because we needed the x to stay. Remember, our goal is to get the x by itself. The only thing is, before I can start getting the x by itself, I have to get the x's together. I can't have x's on two sides. Remember, the goal is x equals a number. If you look at my goal, I don't have x's on both sides. It's only on one. So the first step in reaching that goal is to get rid of one of these x's. Now, remember, think about what you know about equations and what you know about numbers. If I have 0 plus 8, that gives me 8, and that means that that 2x is gone, right? So it's a little different from what you're used to, but really not. If I need 2x to become 0, what do? What plus 2x equals 0? Negative 2x. I need to undo it. We're still, step 3 is to undo addition. Okay, so we're still undoing the addition. It just happens to be addition of an x. 2 x's to be specific. So I subtract or do negative 2x on the left and on the right. Okay, a couple details to remember. X's add with x's. So that's why I lined up my x's together here. Now you can put this step down here where you have the 0, but it's not necessary. So these will cancel. Oops. My 2x and negative 2x will cancel. And I'm left with 8 equals 2x plus negative 10. Remember your integer rules. 4 and negative 2 is positive 2. And then from here, you just solve the two-step equation like you've done over and over and over again. And you get 9 equals x. So again, we're collecting the x's on one side, constants on the other. Okay, so we ended up eliminating this first, right? And then the negative 10 got sent the other direction, right? So it's kind of like if your x's end up getting collected on the right, your constants will get collected on the left. And you'll see the pattern as we go too. Okay, let's look at another. Negative 6x minus 24 equals 62 minus 8x. Yes, the numbers look big, but it's not bad. Let's do our additive inverse first. So we've simplified everything. Now we need to remember our goal. Our goal is to get x by itself on one side. I have x's on both sides. I have constants on both sides. We've got to collect the x's together on one side and the constants together on the other. Something's got to move. You could move anything. Okay, you could look at this and say, I want to get rid of the negative 24. And you could add 24 to both sides. You get to do whatever you want. What I've showed you is a strategy that helps make your process efficient. It helps you have as much control as possible. Okay, if I add 24 to both sides, now, like, who knows what's going to happen? Now I've got x's on both and just a constant on one, and that might, throw you off. So again, we want to eliminate the x with a smaller coefficient. I have negative 6 x's on the left, negative 8 on the right. Now, even though the digit 8 is bigger than the digit 6, negative 8 is actually smaller. Having negative $8 means I have less money than you if you have negative $6 in your bank account. We're both broke, but I have less money. So because negative 8 is smaller, I'm going to eliminate this x first by adding 8x to both sides. Remember, I can add whatever I want to both sides. You need to use strategy and decide what can I add, what x can I add to both sides that will help me get to my goal. Negative 8x plus positive 8x eliminates to 0. Negative 6 plus positive 8 is 2x. Then just bring down the rest of my equation. And what you'll notice is by picking the smaller coefficient of x, you end up with positive x's in your two-step equation. And keep that in mind as we go through these examples, and you'll notice every time, as long as I pick the smaller coefficient, because we're using opposites, I end up with a positive. Just keep your eye on that pattern. It's pretty cool. That's why we choose the smaller coefficient of x. That just keeps things positive, and whenever we have positive numbers that we're working with, the chances of making mathematical errors lessen. Okay, so I get 2x, my 24s cancel, and I get 2x equals 86. And x equals 43. Let's look at another one. So copy this example down. Looks a little bit different. Just go with me. So there will be a time where you have x's on both sides, but you don't have constants on both sides. So you have to shift your strategy just a little bit. Everything doesn't change. Again, it's just our strategy we have to adjust just a little bit. And this part of the reason I show you this is to show you that even if we go off the strategy a little bit, that doesn't mean you can't solve these problems. So I just need to double check there's no simplifying to do. There's no subtraction to handle, nothing. Now, normally I would pick the smaller coefficient to eliminate, which would be this, because -3 is smaller than 5. So I do not want you to copy what I'm about to show you. Just watch. Okay, so if you tell yourself, no matter what, I always have to get rid of the smaller coefficient, you can't get in robot mode and think that way, because take it as a best case scenario. Just like with anything, you have a plan, and sometimes you have to adjust the plan a little bit to get the same outcome. So again, do not copy this, just watch. So let's say you're dead set on eliminating -3x from this side. So we add 3x to both sides. On the left, I get 0, and on the right, I get 8x plus 17. That's going to make people nervous. People are going to start freaking out. They see a 0, they're going to put the equal sign in the wrong place, and it's just going to become a disaster. But if you do this, it's okay. Like, you didn't do anything wrong. As long as you trust the process and really go through your arithmetic, you didn't do anything wrong. You just have to adjust your strategy a little bit, because now everything's on the right. And again, you are not copying this, you're just watching. So I want to eliminate the 17 so I can get my x by itself. Now I have x's on one side, constants on the other, and I could finish it. So even though it went a little crazy on the left-hand side, I'm still okay. Nothing is wrong. I didn't ruin anything. But it does leave you open to some errors, because a 0 shows up, and it could easily on a test or a quiz kind of give you a little bit of a heart attack, and then you forget what to do. So now you're going to do this part with me. When you look at this, okay, part of strategy is being able to understand what's happening and adjust when needed. Strategy is not the same as memorizing. Okay, strategy is a plan, and the plan could change. So if I look at this and I say, okay, well, -3 is smaller. But if I get rid of -3 on the left, I have nothing over there. And that kind of makes me nervous. So I'm actually going to eliminate the 5x. Because remember, our goal is x equals. And to get x equals, I have to make sure I have x's on one side, constants on the other. I already have 3 negative x's just waiting for me on the left-hand side. Why not get the rest over there? So I'm going to undo the addition between 5x and 17 by subtracting 5x, or using -5x. Mathematically, everything's correct. I picked something and I got rid of it. I undid the addition. These cancel, and I'm left with 17 equals -3 and -5 make -8x. And if you notice, the other way I just showed you got me 8x equals -17. I'm going to end up with the same exact answer no matter what. But again, I had to adjust the strategy a little bit so that I didn't get myself in a position where I started getting nervous that I did something wrong. Oops, that's not 18, it's 8. And sometimes the hardest part about solving these is that you do have options, and you do have to make some thoughtful decisions. And it's difficult just because, it's like four forks in the road, and they all can get you to the end, but each one has some different obstacles, and it'll make you nervous deciding, like, am I going to pick the right one? Or am I going to pick the easiest one or the most efficient one? Well, they'll all get you to the end. So work hard and you'll get through any of them. Example 4. All right, now we're back to x's on both sides and constants on both sides. So let's complete our additive inverse first, get rid of that subtraction. So remember, step number 2 after we simplify is to remember our goal is x equals a number. And to get that goal, we need to collect our x's together on one side and our constants together on the other. So I want to eliminate an x first, either the x on the left-hand side or the x on the right-hand side. The strategy is to choose the x that has the smaller coefficient. Now, this x is actually a -1, right? -1 is smaller, so that's the one I would move to both sides, to the other side. If you want, like if you're feeling comfortable, you can try eliminating the 2x and see if you get the same answer as me. But again, I like to use the x with the smaller coefficient because then I end up with positives. These cancel, and I have 19 equals 2x plus 1x is 3x plus 49, and then just solve. I get -30 equals 3x, x equals -10. Now you don't have to copy this down, but I just want you to see, just so you know, that I could have picked any number. I could have picked the other, this 2x to eliminate first. So again, don't copy this down, just watch. But let's say you wanted to eliminate the 2x first with a -2x. On the left-hand side, I get 19 plus -1x plus -2x is -3x. And I'm left with a +4 on the right. Oops, sorry, 49. Okay, -19 on both sides. I get -3x equals 30. Multiply each side by -1/3. And I get x equals -10. So again, you get to pick. There are four things here. You got to start eliminating something. You pick whatever you want to undo. Undo the addition on anything. I could have subtracted 19 from both sides, or had -19 on both sides. I could have had -49 on both sides. I could have picked any of those. You will get the same answer. What I suggest is just a strategy. Okay, guided practice. I want you to try this one on your own. Push pause, copy the problem down, work it out, and then hit play, and I'll have it all worked out for you. See how you do. All right. Hopefully you got x equals 12. So take a second and compare your work to mine. You may have went a different route than I did. If you got the same answer and everything is done mathematically correct and you use a different strategy, awesome. If you got it wrong, let me know and get some help. Okay, try this one on your own. Hit pause, try it, and then come back to see if you're right. Okay, you should have gotten x equals 2. Take a second and compare your work to mine. And that's it.